this is Claude talking about his his physics experiment. What's your physics experiment?
So, if I drop the ball right down there.
No, what is the experiment? What's the hypothesis?
So, the hypothesis: gravity is always a constant.
Okay, and what is our measurement of gravity as a constant? It's over here. What is it? Point it out.
32 feet each second squared.
Per second squared. That's right. Okay, so if we drop a golf ball from approximately 4.5 to 5 feet, stop it. If we drop a golf ball from approximately 4.5 to 5 feet, we have to figure out how long it'll take for that golf ball to hit the ground, right?
Yes.
Okay? So let's show our math on it. So what do we have to do? First off, we have to multiply and get our feet per second squared into feet per second, or into feet and seconds, right?
Yes.
So in order to do that, we multiply times our height that we dropped the ball from, which was approximately 5 feet.
Yes, very true.
Okay. All right. So let's show how we did it. So we multiplied 32 feet per second squared times what?
10.
No.
5.
Times 5, and what did we get?
160.
160 feet squared over what? Over seconds squared.
Oh, okay.
See, over seconds squared. Look, point it out.
Over second square.
That's right. Now, we did a square root on that, and we had to use the calculator on it because we're not to that point in math yet. Quit it.
Okay.
We're going to send this to Miss Klingberg. And we did a square root on that, and what did we get after that? What was the square root of 160 feet per second squared?
12.5 feet.
12.65 feet per second. Okay, now we have to divide in order to figure out how fast our object dropped. How many seconds it took. We have to get the seconds alone.
Yes, we do in fact get it.
So what we do over here, we take our 12.65 feet per second and we divide 5 feet by our 12.5 or 12.65 feet per second. And then what do we get, Claude? What number was this?
395.
0.395. And what's the units? What kind of units was it? Was that seconds or was that feet?
Seconds.
That was seconds. All right.
I guess
So
you're right.
come over here, and here's our calculation and our observed times.
Here's the potato guy.
This is very complicated.
We had one static drop, right? Hey, we had one static drop. Show where the static drop is.
So the static
No, that's the horizontal shot.
drop is right down here.
Mm-hmm. And how many of those did we do?
30.
Okay. And what was our average time on it?
Average time. 0.49 seconds.
Okay. And what was our theoretical time?
0.38
to 0.4. Okay. And what was our horizontal average time?
Horizontal average time 0.506 seconds.
Okay. And why do you think we might have gotten a difference in that versus your static drop?
I have no clue.
Yeah, you do. Why do you think?
Because it equals
The barrel might have been off.
it goes up then it goes down.
Well, we tried to shoot directly horizontal, right?
Yes.
We had everything level. So do you think maybe the barrel could have moved between shots? Quit.
Yes.
Back up. Do you think the barrel may have moved between shots?
Yes.
Okay. What about the stopwatch?
The stopwatch.
Okay. So what kind of error is that called?
The difference.
No. What kind of error is that called? When it's caused by you? Human error.
Human error.
There you go. Okay. And so did our times between our horizontal shot and our drop time, were they pretty close?
No.
Yeah, they were.
I mean, yes.
How close were they?
Like, I don't know.
They were about a 100th of a second difference. So that's not a lot.
Yep, it's very long.
All right. Good job, Claude.
This is